right, our last section in chapter 7 is going to talk about the one piece sort of decimals that we haven't talked about yet, and that's percents, okay? And partly related to percents is this idea of interest, so it's going to come into play at the little end of the end of this particular section as well. So to start with, I want to talk about the phrase or the word percent and where it comes from. Percent actually means per hundred, as in our term cent. Our penny, our cent, is actually 1/100th of a dollar. Okay? So when we talk about in percent, we actually talk about in over 100. That's what it means. Okay? And you guys know that when you talk about a penny, right? If you have 15 pennies, that's 15 out of 100, or 15 out of a dollar, which is worth 100 pennies. So there's two different ways to turn a number into a percent that your book shows. One way of doing that is to write whatever the number is over 100. Okay? So if you were to write 7.9 and you were to express it as something over 100, what ends up happening is the 7.9 ends up getting multiplied by the number 100. So this 7.9 becomes 790, and that is 790 per 100, or 790 per cent. Another way to think about it is in terms of proportions. We've done proportions once before. We're going to encounter them far more later in this particular section. But the idea of doing a proportion is to write our number that we're dealing with, which is not a percent yet, but just a number, over the number 1, and then to write the number n over the percent, or the number per hundred. And then you can cross multiply, right? So you have 7.9 times 100, and you've got equals n. So the result is still the same thing. You end up multiplying times 100. And we've talked before about multiplying by 100, how nice it is, because when you multiply by a power of 10, what happens? The decimal point, it may go away, but at least it moves, right? And when we multiply by 100, it moves how many places? 2 places. Which way? To the right. 2 places to the right. So this number becomes 790 because we've moved the decimal point 2 places to the right. And then, of course, it's percent at the end. All right, so we're going to do that. We're going to do that with the numbers 42.6 and then the number 8 over 3, okay? So 42.6, one way to do this is to simply multiply by what? 100. And so we can think about that as writing it, oops, yeah, we'll do it this way. Writing it over the number 100. So if I were to multiply 42.6 times 100, what would I get? 4,260, which would then be represented as 4,260 per cent. You don't have to show it this way, but this is one of the options. I want to do part B in the other option, that method number 2 that I just showed you, because it's already in fractional form. So I can actually set this up as a fraction 8 over 3 to be equal to some n value over 100. That was method 2 over here, right? Set it up using a proportion. So if I set this up using a proportion, I can cross multiply. What will I have? Okay, 3n equals 800. And then what? Divide by 3. We can take ourselves over here and actually do the division. 800 divided by 3. How many times will 3 go into 8? 2. So 2 times 3 is 6. So that's 20 left over. So how many times will 3 go into 20? 6. So that's a 2 left over. 6 again. And the 6s are going to keep going, right? Here's my decimal point. I'm going to have 6 repeating there because I can keep getting that remainder of 2 over and over again, like in the last section. So this is 266.6%, or if you prefer, you could write it as 266 2/3%. It doesn't matter which one to me, but either one would be correct. Oh yes, I'm sorry, thank you. Okay, move stuff there, yes. Of course, if it told you to round, you could round it, but yes, otherwise you wouldn't have it. Okay, we're actually going to go the other direction now, I believe. Let's see. Yes, we're going to take a percent and turn it into a regular number, okay? So when somebody tells you at the grocery store something is 50% off, and you want to actually use that to do a calculation, you usually don't use the number 50. Okay, so you guys may not remember, hopefully you remember that you know what number you use instead of 50%, the number 50, you use what number? 0.5. You turn it into a decimal in order to do that, right? So that's what this is referring to. And basically, there's really just one thing you do. You write the number over 100, whatever that number is. So this one is actually already 4.5%, 4.5%. So I can write the number 4.5 over 100. That is actually this written as a number now. Okay? Now, it's not very clean and it's not very nice, and it wouldn't use it very well to a calculation with it written this way. But when I divide by 100, just like when I multiply by 100, the net effect is that I move the decimal point. And I still move the decimal point 2 places. Which way do I move it now? I move it to the left because I'm dividing. So this actually becomes a smaller number because I'm dividing by 100. Well, it better become smaller, right? I'm dividing by something quite large. So this becomes a decimal point and then 0.45. Because the decimal moves 1 place, 2 places to the left. So as a number, or as a decimal form of a number, this 4.5% is 0.045. This one says 125, so we're going to do the same thing. I'm going to write 125 over 100. And what that really does is it moves my decimal. It moves it 2 to the left. So if I move it 2 to the left, what does this number become? 1.25. And it should make sense that it is bigger than the number 1 because I'm dividing by 100 and 125 is bigger than 100. Okay. Okay, so that's sort of the nitty-gritty of how it works. And here's where we're going to see it work. We're going to see it work a lot with, in this case, finding percents of the values. So there are 3 different sort of applications or phrasing that a problem can take on that use percents and can be solved with proportions. And these are the 3. Where you find the percent of a number, you find what percent one number is of another number, and the third one is you find a number when a percent of that number is known. And examples are really going to help with me explaining these 3 to you, okay? So let me give you an example of each of these. The first one, finding a percent of the number, might look something like this. This doesn't have a lot of context. We'll get to the context ones in a moment. But they boil down to what is 15% of 32. You're trying to find a percentage of a specific number. And you guys use that with sales all the time, right? You go to Kohl's, they do it for you on the sign because they don't think you're smart enough to do it yourself. Maybe, or just maybe because they want it to be easier, right? They tell you how much a new product is because they've got a sign here that says 40% off, 30% off, or whatever. Okay? Second one, finding what percent one number is of another number. It says something like this. What percent of 47 is 12? And you guys do this with your grades all the time. When I hand back my tests to you, the last test I handed back was at 52. And if you wanted to figure out what do I have right now, this is what you're doing. You're figuring out what percentage does this 39 over 52 correspond to? What does that actually mean in terms of a percent? Because we think of our grades in terms of percents, don't we? Yeah. So you use this one, number 2, a lot when you talk about your grades. The last one, finding a number when a percent of a number is known, looks something like this. 13 is 45% of what number? You can use this one again with shopping, and I'll give you sort of an example anyway. So you go home and you've spent, $50, and your significant other says to you, "What in the world?" And you say, "I saved so much money," but you don't know what the original price is because usually the receipt doesn't tell you that. But if you knew what the percent was that you saved, you could go back and figure out, well, but it was a $3,000 whatever, and I only paid $50 for it. Yay, you! Right? That would be awesome. But it would be really difficult for that significant other to argue with you that you did not make a purchase, even if you really didn't have that $50 to spend. Like, really, right? I can turn around and sell it for more than that. Okay, so this kind of stuff, right? So you can talk about what percent you actually would have, or what the original value would have actually been if you knew what percentage you saved. Okay, so we're going to do some examples with these. And as we do these examples, I'm not telling you which one it is. The first thing you're going to actually have to do is decide what kind of problem you're working with. It's actually on the bottom, okay? Because depending on what kind of problem you're working with will depend on how you set the problem up. But the problems do set up always the same way, generally speaking, but depending on which kind of case you're in, case 1, 2, or 3, will depend on where the numbers go in the process. So let's read the problem and first figure out, are we in case 1, 2, or 3? What is the sale price of a softball if the regular price is $6.80, and there is a 25% discount? Okay, $6.80 and a 25% discount. Which case are you in? We are in the first case. It's case number 1. So this said that we have a softball that we know that there is a 25% discount. So that rules out case number 2. Case number 2, I don't know the percent, and I do know the percent in this problem. It's 25%. Okay? So it's either case 1 or case 3. The other thing is that this says that the regular price was $6.80. That means I know the original amount. That's what happens in number 1. I know the original amount. Number 3, I don't. I know the sale amount or the new amount. So I'm in case 1. So this problem is problem type number 1. All right, so let me show you how this works. We're always going to be setting up a proportion for these, okay? On your test too, you're going to set up proportions. These are all proportions, but they're fabulous, and here's why. These proportions are dealing with percentages, which means I've always got a number over 100, because this is always out of 100%. This is 25 out of 100, I know, so the 25 goes here. Okay? And then the other thing is that the original amount is always on bottom, and the new amount, the percentage off amount or whatever, is on top. But we have to be a little bit careful. So let me write this down first. This is the original, and this is the new or the discount. Okay, so here's where we have to be careful. We have to be careful because what this actually says is that there's a 25% discount, and I've got a product that it was $6.80 at the beginning. And I'm asked for what's the sale price. If I set the problem up like I am right now, and I continue, and I put in the original $6.80 down here, and I put an X in up here, will I find from this specific little piece of information the sale price? No. What will I find? I found the discount, right? I found out how much I saved, which is fine. We can do that. We just have to remember at the end to subtract. If you don't want to have to remember at the end to subtract, what else could you do?
Put 75 over 100.
And why, Heather?
Because that's you're going to pay 75% of it, right? Here.
Right, we could put a 75% here because 75% is what I pay. Does that make sense? If the sale price is 25% off, then I'm paying 75% of the cost of the product, or the original price of the product. All right, and then from this form, you guys know what to do because we've talked about proportions before. And it's actually really nice because I've got a 100 in there, so the multiplication on one portion of it is easy. All right, so grab your calculator if you'd like. We're going to multiply 6.8 times 75. And what are we going to get? What is it? 510. Then what? Divide by 100. And what am I going to get? 510. And it's always good to sort of make sure that that's a reasonable amount. If we'd gotten 1010, this would be a problem. Because I'd be telling you that the sale price was more than the original price. Yeah? So we're in the ballpark, at least in the right answer, right? We've got something smaller, but not significantly smaller. It's only a 25% discount on a $7 purchase, right? It's going to be somewhat smaller, so 510 makes sense, and it is correct. So the new price is $5.10. And make sure you're putting those units on there. That dollar sign matters. It affects the problem. Okay? All right, let's do another one. You ready? Mort bought his house in 2008 for $159,000. It was recently appraised for $195,000. Yay, Mort. What is the approximate percent of increase in the value of his house to the nearest percent? So, first issue, which case am I in? How do you know it's number 2? You guys came about that really quickly. It doesn't have the percent. It's the only one, right? So if you are not given the percent in the problem, you're in case number 2. in fact, you're asked to find it. That was what the question actually asked you to do too, right? Yeah. So we're in case number 2. Case number 2 sets up just like case number 1. We've got something over 100, and what we're looking for this time is exactly the percent. It's the value over 100. Now we need to be careful about how the problem's worded and what we're asked to actually find. In 2008, it was 159,000. Recently, it was 195,000. The question asked me to find the approximate percent of increase in the value of the house. So what do you think we could do? There's several things we could do. Somebody suggest something. Okay, so we could, because it asks me about amount of increase, right? Percent of increase. So we could put the increase on top over the original amount. That's a good way to go, because if I do that, then I found my answer when I'm done with this proportion and there's nothing else to do afterwards. Are you with me? If you decide to put the new price, that's the 195,000 over the 159,000, it's okay. It's just that you're not done when you get to the answer of x equals. Does that make sense? You actually have to figure out how much more than 100 was that new percentage. So if we do this from the get-go, we only have to do one equation, one setup, and then the answer comes as the immediate result of that, which is kind of nice. So if I do this, my original amount was 159,000. What was the amount of his increase? 36,000. So the house increased $36,000 in value. And now I have a proportion. Yes. Yes, it will, and then you have to multiply by 102%. Yeah, and that's the same thing as if we cross multiply. So yeah, you can do it from that way too. That's not a problem. Yeah, I'm going to do it this way just because we keep going with the cross multiplication, but you can do whatever you like on that one, and that's no problem. So if I deal with this as a proportion with the cross multiplication, I have 159,000 x on the left, and I have 36,000, and then I need 2 more zeros, right? Which gives me actually 3.6 million on the right. And then I would divide by the 159,000. So my numbers end up being just a little bit bigger to work with if I deal with it like this, right, Brendan? Yeah. But they're actually the same numbers, just extra zeros attached. So you grab your calculator and you divide 3.6 million by 159,000. What do you get? $22.6. Do you have a confirmation of calculator?
Yes.
Yeah. Okay. All right. So 22.6%. Again, the unit is percent needs to be there. So the house went up in value by almost 23%. Like I said, game worked. Okay. One more. A ski area reports that 80% of its runs are open. They do this in the ski community. They like to report things just like this. If there are 60 runs open, how many runs are there at the ski area? Which case am I in? 3. I better be because I sort of tend to like give you an example of each one, right? By default here. It is case 3. Let's actually talk about why though. Okay, so on case 3, I know it's a percent. I've got a percent given to me in the problem, so I'm either between 1 or 3. And then in number 3, we talked about the issue is I know the discounted amount. I know the percentage amount, and I want to find the original amount. And that's exactly what this problem said. I know that there's a certain percentage of these runs open, and that equates to a certain number of them, but I want to figure out how many runs are on the ski resort. So I start out with the 100, and I have the 80. Where will my 60 go? On top. Because the 60 corresponds to that 80%, right? And what I don't know is what corresponds to 100% of the runs being open. And that's what I'm trying to find. So I could cross multiply. I have 80x equals 6,000, sorry. Too many, 6,000. 6,000. So what is 6,000 divided by 80? Note, it better be more than 60. 75? All right. So there's 75 what? Runs. 75 runs, ski runs, something like that. That's actually how many the resort actually has. And all of them doesn't make that. Any question on these? You can do that, that's fine. Just set it up as a proportion to start with. Okay. The nice thing I should say about proportions with these is that it always works. You can always set something up with the over 100 and plugging in where the values go to start with. It's very reasonable to do. You can see it, it's very clear. And so are there other ways to do these problems? Absolutely. There are ways to do it straight out with equations. We can talk about the words of and things like that and what that means in math symbols and all that's fine. It's just that it's not quite so visual. And so this has a very good visual pull to it so students can see where things go very quickly. All right, I want to talk about a couple other things in this section. The next one is mental math. You guys use mental math a lot. Sometimes you use mental math to estimate, and sometimes you use it to find exact values. So we're going to start talking about a little bit about mental math, and I want us to look about these values here at what fraction they correspond to. Okay? So that's where we're going to start. So what is 25% as a fraction? Okay, as a decimal it would be 0.25. As a fraction it would be 1/4, right? How about 50%? 1/2? 75%? 3/4? 33 and 1/3%. 1/3. 66 and 2/3%. That's 2/3. Whoops, that's a 3. What is 10%? That is 1/10. And a 1%? 1/100. So I want to talk about how we use mental math, and I'm going to give you a few examples, and we'll talk about where you see this kind of example potentially being used as well. So these have the ability that we can set them up with proportions. I mean, they do, no question about it. We can figure out if it is 1, 2, or 3, but that's not the directions. The directions say using mental math. I understand mental math means in your head, right? The problem is that I can't get in your head and see what your head is saying or thinking. So you're going to show me something that is, when you do these, even if it doesn't tell you, write them out. If you get to a test, I'm going to want you to, so be practicing. I did this by thinking about this, this, and this. Okay? So let's talk about this. 15% of 42. How could you use mental math to find 15%? So I guarantee it's not multiplied by 0.15. What could you do? We could find 10% and then we could find 5%. And then what could we do with those values? Add them together. Okay, so how could we find 10% mentally? You just move the decimal over. All right, so the first thing that we're suggesting is to find 10%, and we're doing it by moving the decimal. So what is 10% of $42? $4.20. Then how am I going to find 5%? We're going to do it by halving 420. What's half of 420? 210, right? We add them together and we get 630. And you could do all that in your head. I know that you could. But I want you to show me this much of it so that I can see what your head is saying. Does that make sense? Okay, that lets me see what's going on. Where might you find 15%? In what situation might you actually do that? You know? A store, you might have a discount of 15% discount. A lot of people use 15% as a tip amount too. So you might actually see somebody using something like this when they're figuring out a tip on something. How about 20%? How can we find 20% in our head?
I always just take the first two numbers and multiply it by 2.
Okay, and then You say the first two numbers. Does it matter how big the number is? If it's always going to be the first two? Like, for instance, if I take 280 and I multiply the first two numbers by 2, then that would give me 56, right? But if I had the number 2800, I would also get 56.
What was it? 560.
Okay, why? So you told me a minute ago the first two numbers.
Well, if like, for the 282 times 0 is 0, so I mean you would, what she was saying, the first, if there's a 0 at the end, it would just be 0, I guess.
But
Just
if
be
that's the
flat.
case, why does 280 give me 56, but 2800 also gives me 56? I'm just gonna use
Knock a 0 off the end.
Okay, so let's say it that way instead. We're going to just eliminate one of the decimal, or one of the locations, right? The units place we can ignore. So if we're thinking about it from your perspective, Heather, we can ignore the units place, and then we can multiply everything by 2. That would work. Okay? What else can work? You can find the 10% and times it by 2, which is exactly what you're doing, right?
Yeah.
And that's why you're eliminating one location of a decimal, or not a decimal point, but of the units place. All right, so we're going to do, in some way, shape, or form, we're going to multiply by 20%. Let me move these over here. So I'm going to write it the way Devin suggested, but what you have is fine, but with a little bit of a language change, like what we were talking about, okay, Heather? So we're going to find 10% by moving the decimal. And then double it. So 10%, what's 10% of 280? 28. And then I double it, so there's your multiplying by 2 that you're talking about, Heather, to give me the 56. And some people use 20% in the 10 as well. So that actually comes about as well. How would you get 5%? 10% and half it. We actually already did it once, right? For the first one. So we can find 10% and half it. So we find 10% as above. We already described this, so I'm not going to keep doing it over again. And half it. So what is 10%? 2.8. And then halved would give me 1.4. When we were in Ethiopia this summer, we had some difficulty with students doing this. And the reason they needed to find 5% was because the going rate for tips in Ethiopia is a 5% tip rate. That's what they use there. I mean, that's just the norm. And the person who was handling our money was struggling a little bit to do this because of this idea. She was having some difficulty with this mental math. Okay, the 5% was actually something she needed to be able to calculate when we were doing it. And I kept explaining it in this exact same way that Brendan said. Just take 10%, plug in the decimal, and then half it. You've got a different money issue, currency issue too, which makes things a little bit feel a little bit weird. But that's how you do 5%, or can do 5%. All right, we have more than one way again, especially on part D. What can we do on part D? 25%. Divide by 4 is really nice, especially for the particular number I chose, right? So one option is we could divide by 4. What else could we do? Maybe I should say, why does divide by 4 work? Let me stop there. 25% is 1/4, so dividing by 4. So what did I get if I do that? 21. What else could you do if it weren't something that was so nicely divisible by 4? Yeah, you could do 10% and double it to give you the 20%, and then you could take that 10% and half it to give you 5%. This is basically what we've done in the earlier problems, right? Yeah. So kind of combine B and C together. All right, a few thought-provoking questions here, a couple of them anyway. Does 0.4 equal 0.4%? No. Why not? Okay, so let me start with Mackenzie because you started talking about the point before over here. 40%. So 0.4 equals something over 100, particularly it's 40 over 100. That's how you would write that as a fraction, right? 40 over 100. So this is 40%. Okay, which is clearly not equal to 0.4%. So we can think about moving from right to left, or sorry, left to right. Brendan, you were doing it the other direction. So let's say or. You wanted to talk about this 0.4%. So what does 0.4% mean?
It's already been put over.
Well, if I want to turn it back into a decimal form, I would put it over 100. So this is 0.4 out of 100. Right? And if you have 0.4 out of 100, 0.4%, we would move that decimal, and what would we get? Right? The decimal to the left would be 0.004. So the answer is no, these do not equal the same thing. And I'm not going to write any language with them, but you would if this were a person kind of question on your test or on your homework, right? You would explain, you use words to talk through what we just talked through out loud, either with what's in red or with what's in blue. You don't need both of them. One or the other is sufficient to describe why this doesn't work, right? Getting some blanks here. Are we okay with this one? Okay. All right, last one. Why is it possible, last one of these type, I should say. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price?
You'd be paying people to take it.
Yeah.
Basically.
Paying for their service.
Okay, so if we were, let's use a number example so that we can talk about it. Let's say that I have a $20 product in my store. What do you want it to be? A shirt? What do you shirt? $20 product. If I were to increase the price of that $20 product 150%, what would happen? That'd be a 50% price increase.
Okay, I was thinking better.
It'd be $50
It'd be $50 when I was done.
Almost 30.
Okay, so 100% increase in the price means you double the price. And that's what it means, right? It means you increase it by what it's already worth. And then we have 50% more than that. So if I started with $20, it would become a $50 product. So you can always do this like what Devin said. You can always add more to it, right? You can always increase. What happens if I take that same $20 shirt and I decrease it 150%? You were talking about this.
You would be taking.
I would, right?
Give me $2.
You'd be giving them $10 to take that shirt outside your door. Yeah, so it becomes negative is a problem, right? So when I decrease something by a percentage, I actually take something away, and there's only so much to take away. 100%. That's the amount. I mean, you can't take any more than 100% away. All right, so write some language down to go along with this on your paper. And then we're going to get to the last part of the section, which is interest. Here's what we're going to do. I'm going to talk about this one last slide. We are going to finish the last 2 slides of information next Tuesday. I would suggest that you do the homework that's not related to interest over the weekend. Oh, I'm sorry, 2 pages of slides. I got it upside down. Yes, I know you're right. So do the problems on your homework that are not related to interest on something. We haven't done any things of those. If you know how to do this already and want to, that's fine. But hold off on that. I'll take questions on Tuesday about the stuff that's not related to interest, and we'll do the group work for this section on Tuesday as well. Okay, your test is Thursday, so don't wait until Tuesday to do all of this, because then you're going to have a whole huge section of material between Tuesday and Thursday, plus studying for the test and every other section. Sound good? All right, let's cover this last slide right here before we leave. Interest is the amount of money you pay or earn to borrow or lend money. So when you put the money in the bank in a savings account, it's the money you make on your money. When you borrow the money from the bank for the car loan, it's the amount you pay for the luxury of borrowing and having borrowed their money. That's what interest is, and it's either way, right? It always benefits somebody and is a detriment to somebody else. That's what interest is. So principal is the original amount that you use to determine the interest. So it's the original amount of money you put into the account or the original amount of money that you borrowed from those from that car dealership or whatever. Okay, so that's what the principal is. Interest rate is the percent that you use to determine the interest. And then there's two ways to calculate interest, two practical experience ways to calculate your interest. One is simple interest, and one is compound interest. You'll notice there's formulas for these. Each of these have letters in them. Some of them are similar. So A is the amount of money that you either owe or are owed for having made that transaction. P is the principal, the original amount of your money. This R is the interest rate as a decimal. So if it's 5%, you don't put 5 in for R. What do you put in for R? 0.05. You have to make sure that you change that interest rate R into a decimal form of that number. T is time, and time is always in years for interest problems. So if somebody talks to you about a loan that's for 18 months, and you put 18 in, that's a problem. What should you put in if it was an 18-month loan? 1.5, that's 1.5 years. So the time is always in years, the interest rate R is always in a decimal form, not the percent form. There's one other letter that's in the compound interest formula. What is it? Can you tell from where you're sitting? The letter N. The letter N is only in the compound interest formula because it only applies because it's talking about how often something compounds. So you might get an account or a loan or something that compounds monthly. How many times would that mean that it compounds in a year? 12. So N would be 12. What if it compounds annually? That's once. What about semi-annually? That's twice. Semi-annual sale, right? JCPenney, whatever, fall, winter, twice a year. Okay. What about quarterly? 4. Quarterly means 4 times a year. You could do daily. 365. We're not going to go with 0.4 or 0.25. Whatever. We don't have to worry about the extra day of year stuff. Okay. But these are what you would use for the N value, right? It depends on how often something's compounded. Now, generally speaking, the problems you're going to work with and you will see next time will tell you it's simple interest or it's compound interest. Or you'll have a phrase in there that says something like compounded monthly. Compounded monthly means you use compound interest. So it's not usually terribly difficult to figure out which formula you use, but it is something to be aware of, that you actually have to make a decision. Don't just go grab one and think I'm going to move forward with this and, oh, that's just a little bit of piece of extra information. Probably not, okay? You're probably missing something if you've got extra information. That's sort of what happens in book problems, right? We don't usually throw extra information in. Sometimes we're not usually. All right, we'll do examples of this next time. Have a wonderful weekend, folks, and I will see you